Let me get it up there for you. All right, we got it? No. Okay, so we're going to talk today. So yesterday we did the geometry version of unit circle. Okay, we learned how to do the unit circle and find things using the triangles. All right, but there's another way to do it. We can use coordinates as well. So that's the gap we're going to bridge today. We'll see how far we get today. I'm assuming we'll only get through the first part because we got a lot to write down on our unit circle. Okay. So the unit circle is a circle that we learned yesterday that is exactly 1 unit wide, right? And yesterday we talked about these coordinates yesterday, right? We can go out 1, up 0, out 0, up 1, out -1, up 0, and out 0, down 1. All right, so that's the first thing I draw when I draw myself a picture of a unit circle, okay? All right, that you need to fill in, right? Fill that in. Okay, so each value of the unit circle corresponds to a set of coordinates. So, and we talked yesterday about how that set of coordinates is x comma y. Okay, and the x comma y stands for cosine comma sine. It's in alphabetical order. Okay, so those triangles correspond to a coordinate. All right, so what we're going to do here is we're going to determine the exact value of the 6 trig functions of the angle theta, okay? And we did learn a few things yesterday that we're going to try to use in here today, okay? So we already know that the first one is cosine and the second one is sine. So I'm going to write the sine of theta equals what? Just read the y value. 3/5. What do we easily get from sine? Cosecant. So cosecant is going to be what? 5/3. Good. All right. We can also read the cosine right out of there. -4/5. Okay. What does that mean? What do we get easily from cosine? Secant. Good. And the secant is what? -5/4. Excellent. Yesterday we talked about a trig identity for tangent, right? We said that the tangent is the sine divided by the cosine. All right, so let's do that for the tangent. The sine is 3/5 The cosine is negative 4 over 5. Remember how we flip and multiply those things? Okay, what happens with the 5s? They cancel, so my tangent is negative 3 over 4. What do we easily get from tangent? Cotangent. And so what would our cotangent be? Negative 4 over 3. All right. Because I know some of you are advanced enough to handle this, okay? If this doesn't work for you, it's okay. What do you notice? What eventually happens with these 5s? They cancel out, right? If you see this, if you see a complex fraction like that, and you see that those denominators are the same, couldn't we just cancel them here? Yeah, because you know the process is, we're going to flip it and multiply, and they're going to cancel anyways. So if you see the shortcut, you are more than welcome to take it, okay? Usually I expect that usually by the end of your first year of calculus that we can see some of that, okay? All right, let's do this one, okay? Actually that one, why don't you guys try that one on your own, okay? See if you can get that one done. Same process as the last one. All right, let's check it. So, what did you guys get for the sine? Good. Okay, what do we easily get from sine, everybody? Cosecant. What'd you get for cosecant? Good. All right. What'd you get for the cosine? And what do we easily get from cosine? What ratio do we easily get? Secant of theta, which turns out to be negative 13 over 5. All right, the tangent, what do I put on the top? Good, and on the bottom? Good, and if you didn't see the shortcut, we would go ahead and flip and multiply. Cancel the 13s. What happens, actually, I could have done here, what happens with those negatives? Cancel to positive, so we have 12 over 5. What do we easily get from tangent? Cotangent, and that is 12 over 5. I want you to observe this. Remember how we learned all students take calculus yesterday? All right, all of them are positive. So in this quadrant here, the tangent should be positive. Did the tangent and cotangent end up positive? Was everything else negative? Yeah, okay. All right, so here goes the next part of this before we get into... All right, so well, here's what I want you to do now is you're going to get out a glue stick, okay, and we're going to glue on that extra part. You might want to make it so your little, it's up to you whether you take it all apart and put the little brad on again. When you're gluing this on, make sure it ends up on there the right way so the coordinates look correct, okay? Your coordinates should look like this, okay? So when you glue it on, make sure they're tilted the right way, okay? So, and like that, so they should be tilted the correct direction. So I'll give you about 2 minutes to get it glued on, at the most. So you can poke it in with a pen, that's fine, okay? If you want to poke your little brad all the way through, that would be a good idea. And then you also need to write your name on the back of your new back, okay? Make sure you glue it down. Make sure your axes line up. And again, make sure that it is... Your green should be pointed towards the top, right? So make sure your coordinates are on there correctly. Again, make sure your green X is going vertically. If your green X is not vertical, you're going to get the wrong things written down. So really double check that. Okay? I'll give you about another 30 seconds to get it glued, and then we're going to fill it in. Okay, this is going to look overwhelming, okay? Eventually it's not going to be as bad as it seems, but I'm going to give you about 4 or 5 minutes. I want you to get this filled out. You need to make sure you're doing this accurately because, again, you get to use this on the test, right? So, looks a little different than yours, but you can see that the coordinate that's supposed to go on your outer, match it with the, the radian measure that's on the line, okay? So I'm going to give you about 4 or 5 minutes. Get all of those coordinates filled out. Make sure you have the negatives all in the correct place. Okay. Eventually, you're going to memorize how to set that up. We're not ready for that yet. Okay. But eventually, that's coming. In calc, I expect it to be memorized. You'll be fine. We'll get you there. I promise. I know we're not ready yet. Double check it if you're done. Make sure you have all the negatives in the right places. In quadrant 2 over here. It's not working very well. In quadrant 2, the negatives should be on your x values. In quadrant 3, it should be on both values. And then in quadrant 4, the negative should be on the y value. So double check to make sure you've got the negatives in the right spot. All right, what we're going to do now is I'm going to show you how to do the exact same thing we did yesterday, but instead of using the triangles, we're going to use the coordinates. You can pick which one you want to use on the test next week. Okay, you get to do the triangles, you get to do the coordinates. I don't care. I'm teaching you 2 different techniques. Just like there's more than one way to factor, there's more than one way to do this. Okay? Eventually, you're going to want to move towards the coordinates. Okay, that's where I would go, is I would move, because that's what we're going to use in AP Calc most of the time. Okay? All right, so what we're supposed to do is find the point on the unit circle that corresponds to the real number t. Okay, all we're doing is looking for the point. Okay, so on the unit circle, I want you to look for 2 pi over 3. Which quadrant is it in? Second quadrant. Read me the coordinates. What are the coordinates? Mm-hmm. Good, perfect. So all they want you to do is identify where it is on the unit circle. Okay? That's it. All right. Is negative pi over 4 on the unit circle? Yes or no? No. Okay. So I know that I've got to add or subtract 2 pi, right? So in over 4 world, what do I have to add? 8 pi over 4. So what do I get when I add 8 pi over 4? 7 pi over 4. So look for 7 pi over 4. What quadrant is it in? Fourth quadrant. All right, read me the coordinates of 7 pi over 4. Negative square root of 2 over 2. That's it. That's all they wanted us to do. Okay? All right. I want you guys to try 5. So everybody find 5 pi over 6 and write down the coordinate for 5 pi over 6. Okay, what quadrant is it in? Second quadrant. All right, what's the coordinate? Good. 1/2. Perfect. All right. Now they want us to find the sine, the cosine, and the tangent of whatever number they give us. Okay? So, let's talk about pi over 6. What quadrant is it in? First quadrant. Okay? What is the coordinate? Tell me what the coordinate is. Good. All right. And we know that it is the cosine comma the sine. So the sine of pi over 6 equals what? Just read it out of the coordinate. What do we get? 1 over 2. The cosine of pi over 6, read it out of the coordinate. What do we get? Square root of 3 over 2. And then the tangent, remember, is the sine divided by the cosine. So we've got, what's the sine? 1 over 2, and the cosine is? Good, which means, you see why I taught you the shortcut on the, oops, I didn't flip it well, did I? We got to flip and multiply. Oh, I think I've got the right thing now. So 2 over square root of 3, so that's going to cancel. So you get 1 over square root of 3. How do I get the radical 3 out of the denominator? Multiply by square root of 3 over square root of 3, so I really get square root of 3 over 3. Okay, just for a second so you believe me on this, what color is let's think about yesterday. What color is the pi over 6? Blue triangle, right? So we're looking at our 30-degree triangle, which had a 1, a 2, and a square root of 3. If I look at the sine, or the SO of that triangle, isn't it the opposite over the... Isn't that what we got for our coordinate? Yeah, okay. The cosine would be the adjacent over the hypotenuse, and that's what we got for our coordinate. Okay? So, either way you do it, you're going to get the same answer as long as you have the information recorded correctly on your unit circle. Huh? Because you have to understand that there's a connection between the 30, 60, 90 triangles and the coordinates. Okay? So, we try to develop that connection. I personally, I think the coordinates are way easier, okay, than the triangles. But you can always go back to the triangle if you had to. Okay? All right. Let's look at this one. Let's see, how many more of these are there? Oh. All right. So we've got the sine. So wait. First of all, where is 5 pi over 4? Which quadrant? 3. Perfect. All right. What are the coordinates at 5 pi over 4?
Negative square root of 2 over 2.
Mm-hmm. Good. And so we know the cosine and the sine are the same there. So we've got the sine. Oh, this time I have to do all 6 of them, right? All right, the sine of 5 pi over 4 is going to be what? Negative square root of 2 over 2. And if I've got to do all 6, what do we get very easily from the sine? Cosecant. All right, of 5 pi over 4. So I have to flip the reciprocal, so I get negative 2 over square root of 2. And we're going to rationalize these. So negative 2 square root of 2 over what? 2, which is really just what? It's really just square root of 2. So I've got negative square root of 2. All right, the cosine of 5 pi over 4. What's the cosine according to that? According to the coordinates? Negative square root of 2 over 2. What do we easily get from the cosine? What other or function? Not cosecant, but secant. Okay. Oops, secant of 5 pi over 4. When I flip the reciprocal, isn't going to be the same as the cosecant? So okay, I don't need to redo all that work. I'm just going to write down negative square root of 2. All right. Tangent of 5 pi over 4. How do I get the tangent? Sine over cosine. So my sine is the negative square root of 2 over 2. And the cosine is also the negative square root of 2 over 2, which reduces to what? 1. Good job. So what does that make the cotangent? Also 1. 5 pi over 4, also 1. Okay? All right. If it's okay with you guys, let's see, how much time do we have? Let's do a few more. If we can get through this, we might be able to work in more extra work time later in the week. Okay? So, I think with the triad ending next week, that's probably a good thing, right? All right. We have to evaluate. So this isn't really that much of an extension beyond what we were just doing. I have to do the same thing we did yesterday. When it says using period as an aid, all that means is we're going to add and subtract 2 pi. Okay? So when we're in over 3 world, how do first of all, do I need to add or subtract? Subtract, because I'm bigger than 2 pi right now. What am I going to subtract? 6 pi over 3. Good. So we have the sine of what, really? 5 pi over 3. Good. Okay. What quadrant is 5 pi over 3 in? Fourth quadrant. All right. What are the coordinates in that fourth quadrant? Should be about right there. Negative square root of 3 over 2. So the sine of 5 pi over 3 would be they only want the sine this time, so the y coordinate, what are we getting? Negative square root of 3 over 2. So imagine that worksheet you did last night if you had the coordinates, right? Okay, it should be a lot easier now. All right, let's look at this one. You don't appreciate the coordinates so much if we don't do the triangles first. Okay. All right. Am I going to add 2 pi or subtract 2 pi this time? Add. And instead of 2 pi, what are we going to use? 8 pi over 4. Excellent. All right, so we've got the cosine of what, really? 3 pi over 4. All right, what quadrant is that in? 2. And what are the coordinates right there?
Negative square root of 2 over 2, square root of 2 over 2.
Good. All right, so what is the cosine? The x value. Good. What is the x value in that case?
Negative square root of 2 over 2.
Perfect. Okay. If they asked us for the secant or the cosecant, obviously you flip it and rationalize. Okay? All right. You have to fill that in?
Yeah.
Okay, so put those in there. I'll show you. These ones are hung on the walls. Okay, so I'll show you where they're at here in a second. Find it? You sure? It's up here 2 times. Okay, so these are the even and odd. They're really identities, and we're going to get into them again later, but they do come up here first. If you look up at the windows, right, they're on both sides of the room. Okay, it's okay to look at the windows during a test, all right? And you notice these have been up all year, right? You wondered what they were for, right? Because AP Calc uses them, but you guys use them too. So this column right here is those even and odd. So if you look at that window over there, that last column there, so because 1 one year they complained that they couldn't see them on one side of the room, so I fixed it so they could see it on both sides of the room. So when I talk about third window, that's the third window, right? That's the first window. Okay, and you notice on that first window are all the reciprocal ones, right? And the one we learned yesterday, the sine over cosine is on that window. Okay? So I'll talk about the first window, first column, and all of that. Okay? So this goes 1, 2, 3. That was the third window that they're on. Okay? Alright. So there are even and odd trig functions, and I think they give them another name eventually too. What you got to know that's a little bit different is on the cosine and the secant, when you have a negative on the inside, it goes away, okay, because it's an even function, all right? On the odd functions, what happens with that negative sign? It goes out front. See how it comes out front in the answer? Okay, so on the odd ones, you have to know that they goes out front. So if you can just remember that the cosine, it goes away, and the secant, it goes away, and everything else goes out front. Okay? All right, let's try what the next couple are here. All right, we're going to use the value of the trig function to evaluate the indicated functions. Okay, so on the sine, what do we know? So we just talked about this with the even and odd identities. What happens with the negative sign when we have sine? It goes out front. So we'd really have negative sine t. What's the value of sine t that they gave us? 1/5. So we'd write negative 1/5. Done. Okay. What about cosecant? Does cosecant go outside? Does the negative go outside, or does it go away? It goes outside as well because it's not cosine or secant, so it's negative cosecant of t. All right. Cosecant is the reciprocal of sine, isn't it? So it's really 5 over 1, or just negative 5, right? Would work. All right, let's try 2 more of those. All right, so the cosine. What do we know about the cosine? When you have a negative on the inside, what happens? It disappears because it's an even function. Okay, so what value did they give us for the cosine of t? 5 over 3, done. All right, what about secant? What do we know about the negative and the secant? It also goes away. And what's secant the reciprocal of? Cosine. So what would we get for our answer? 3 over 5. See, so far trig's easy, right? All right. The last couple are all on the calculator, right? Okay, so remember how I told you that I don't have my calculator going. Do you guys have your calculators on? Okay. So, remember I told you were going to have to make sure you were in the right mode in your calculator? Okay. Notice they give it to you with a pi in it. So if you have the degree symbol, it's in degrees. If you have the pi, what is it in? It's in radians. Okay? So what you all need to do right now, since I don't have mine up there, is you need to go back to your home button, right? So find your home button and go to settings. And then go to your dock settings, right? And then switch the angle to radians. Did I do all that in the right order? All right, and make sure you hit make default. And hit OK. Default. All right. Now we will get the right answer, hopefully. All right, so go ahead and hit your scratch pad. And I want you to type it in exactly the way it looks. So you're going to do sine of 2 pi over 3. Do you all remember where the pi button is? Left-hand side, middle, down by the letters in the middle row. Okay. All right. What are we getting for the answer? 0. Give me 3 decimals. 866. Everybody okay with that? Okay. Do secant of 11 pi over 6. All right, what do we get for that one? It's going to be point something. 1 point. That was bad. 1.1547. So 1.155. Okay, if we're going to round properly. All right, last one. Okay, is it in degrees or radians? How do you know? Is there a degree symbol on it? There is not a degree symbol on it. So this one is in radians. Okay, because there is no degree symbol. Does everybody catch that? So use your calculator in radians and do cotangent of 1.5. 0.071. Is that right? Okay, so here's the deal. We finished what we were supposed to do today and tomorrow. So what I will do is tomorrow I will teach what I was going to teach on Friday, and then we'll make Friday a work catch-up day. Okay? Or maybe we'll see if I can come up with something else to help us review a little bit. The test is scheduled for next Thursday. Okay, and we'll probably leave it on Thursday. I'm not going to bump it up earlier than that. Okay? Yeah, if you want something stamped, you can come see me. Okay? If you're desperate for those stamps, I would make sure you come and see me. Okay?